Hello and welcome to C3D4Me. In today's lesson, we're going to go over drawing in curves from record data. Okay, to begin with, we're going to start with a tangent curve, as that's going to be your simplest. Okay, so let's say we're trying to draw in lot 91 here, and we need to get this curve. Let's start here at the southwesterly corner. And we're going to start with this bearing. South 02 degrees, 52 minutes, 43 seconds west. But we are going northeast, so we're going to just flip that. So pick our first point. Northeast, 2 degrees, 52 minutes, 43 seconds. And a distance of 25.73. Now that brings us to the beginning of our curve. So the most important information we need to look at right now is the radius. The radius of the curve is 20 feet. That means the center point of the curve is 20 feet to the east of our endpoint here. So we need to get to the center of that curve. The easiest way to do that, if you have a tangent curve like this, is to go perpendicular from the end of the line we've just drawn. So we're going to use the line perpendicular command. So it asks us to select an arc or line object. We have a line here. I'm going to select it. Where do we want it? Right at this end. Select specify distance, 20 feet. So this is the center point of our arc. Now there are lots of ways to actually draw in this arc, but my preference is to start with a circle. So we're going to begin our circle here at the center and snap it to the endpoint. So this should give us a 20-foot radius circle, which it did. And now we're going to break it. So our curve is going this way, sort of northeasterly. So we want to break it, specify our first point at the beginning. Let's bring it around here just so we have it going the right direction. Okay, now we have our broken curve, which is now a AutoCAD arc. And let's just go ahead and see what the delta angle of this arc is right now. So I'm going to add a label. And let's pull this off so we can see it a little better. So our current delta angle is 69 degrees, 51 minutes, 27 seconds, and we want it to match here. You can mostly disregard the length because it basically means the same thing as the delta, but the delta is slightly more precise. So you're always going to want to match the deltas rather than focus on the lengths. So to get our deltas to match here, we're going to use the lengthen command, and we're going to want to lengthen by the total, which should already be the default setting. So we're going to go ahead and hit enter, and it'll ask you to specify the total length or angle. And since we're going by angle, we're going to want to type in the letter A for angle. Now specify total angle, and our total angle is pretty simple here, just 90, the letter D for degrees. And now we select the arc, and it updates to 90 degrees. Perfect. There is our tangent curve. Now, there's another type of curve that we're going to have to deal with when dealing with record data from time to time. That's the non-tangent curve. That just means that the center point of the curve is not actually perpendicular to the line it connects to. So in order to draw these in, we're going to need one piece of information, which should be on any recorded document, which has been drafted correctly, which is the radial bearing. So let's just go ahead and start from this corner and work our way into this arc. So I'm going to draw my line by bearing. We're going to go northwest, 62 degrees, 18 minutes, 6 seconds, a distance of 46.17 feet. And now we need to find the center of this non-tangent curve. So we can see here our radial bearing is northeast, 445207, so we're going to enter that. And now we're going to need to know the radius of this curve. And you can see our labels don't have the radius, but we can figure it out from other information provided to us. So we can see our center line here is a radius of 350 feet. And we have a right-of-way width of 28.5 feet. And we're going to go 350 feet minus 28.5 feet because it's offset towards the center of the curve, which gives us a radius of 321.5 feet. So we're going to punch in our distance of 321.5 feet. And that'll give us the center of that curve. Now we're going to do the same thing we did previously. Circle, snap to the center, snap to the end here, and we want to break it again. So we're going to go ahead and break. First point is at our end point, bring it around, and we're just going to be trying to draw in this lot 889, so we're just going to lengthen it to this delta angle. So we're going to go ahead and lengthen the total, the angle, 1 degrees 48 minutes 51 seconds, and lengthen it. Let's go ahead and check our work. Just make sure it turned out right. Radius 321.5 feet, delta 1 degree 48 minutes 51 seconds, length 10.18 feet. Perfect. Now there's a third type of information you might run into. It's less common, but if you're working in surveying, I'm sure you're going to see it at some point. So I had to draw this in myself as a little example because I don't run into this very often. So this is a curve where the only information we have is the radius, the chord bearing, and the chord distance. We don't have the length or delta angle. So to draw this in, we are going to go ahead and create a line by bearing. And let's go ahead and draw this first course in. Northeast, 0 degrees, 100 feet. And this one is pretty easy to actually do. So mostly we have to pay attention here to the chord bearing and chord distance. So our chord bearing, we're going to keep our line going northeast, 37 degrees, and a distance of 60.18 feet. And now we're going to want to use the curve command, start end radius. Now we're going to have to draw this backwards because anything going northerly will end up with the radius point being on the left, but we want it on the right. So we're going to run through this command, start end radius, start point here, our end point is here. We're going to specify our radius of 50 feet. Now, if we are to label this, this will come out exactly as the label on the left. Radius of 50 feet, chord bearing southwest, 37 degrees, chord distance 60.18. That's how it's done. Thanks for watching.